Hi everyone, can you all see the whiteboard? Can everyone see the first question on the whiteboard?
Yes.
Okay. What answers did you get for this question? Okay, good. 5/3 is correct. Ishan, can you explain?
So it says Susie pays for 4 muffins and 3 bananas, and Calvin spends twice as much, paying for 2 muffins and 14 bananas. So basically, you have to multiply Susie, like what she buys, by 2. So you get 8 muffins, or in this case, 8m plus 3b equals 2m plus 16b. Oh no, 8m plus 6b for Susie. And then you just, I just subtracted the 2m, so you get 6m equals 10b. And then you just solve that and you get m equals 1 over 1 2/3 b, which
Good.
is 5/3.
Good. Yep. So in this case, the easiest way is you see that 4 muffins and 3 bananas is what Susie bought, and Calvin spent twice as much to buy 2 muffins and 16 bananas. So then you know that twice of what Susie bought is the same value as what Calvin bought. So 8 muffins and 6 bananas is the same cost as buying 2 muffins and 16 bananas. So then you can figure out, so okay, so then buying 6 muffins is equal to 10 bananas. So the price of a muffin is 10 over 6 times that of a banana, or 5/3 of that of a banana. So this is kind of an algebraic way of doing it. You can also try to pick a value for m and b and see what makes this kind of equality true, and then confirm that you'll get the same ratio here, 5:3. Any questions on this? Okay, let's move on to the second question. Okay, good. 6/5 is correct. Pavan or Preeti, can you explain?
Okay, yeah. So he starts off at the home, and there's a gym on the other side. So he's gonna keep on going infinitely. So there's gonna be 2 points where he stays in between. So that's A and B, which is somewhere near the center.
Mhm.
And then you can realize that since he's going like 3/4 to the right and then 3/4 to the left, like the ratio, if we have like a center between A minus B, A and B, if you make that like X, that's proportional to like, if A and B, like the home to A is 1, the home to B is like 3x, and then the B to the gym is 1. So it's split up like 1 3 3 1 1 3 1.
Mhm.
And then all we do is we find that A is 1/5 of the way, since that's 1, and B is 4/5 of the way, because we do 3 plus 1 over 5.
Mhm.
So once you multiply that by 2, since they said it's 2 kilometers, you get 2/5 and 8/5, as A is 2/5 and B is 8/5. You subtract that, and you get 6/5 as the total answer.
Good. Yep. So yeah, I think the key thing first to see here is that, so if you think about what happens, right? So let me use this slide. So Henry starts from home. He goes 3/4 of the way to the gym. So let's say somewhere here. Then 3/4 of the way back here. Then 3/4 of the way to the gym, 3/4 of the way back home, and so on. And you can imagine this as you're going back and forth. It ends up then, he'll never reach either one, right? And he'll always kind of go to one point that's closer to the gym, and then move to one point that's closer to home, and then back and forth and back and forth. And then at some point, when it says that you go close to walking back and forth between these 2 points, A and B, what happens is basically from B, if you go 3/4 of the way home, you reach A. And from A, when you go 3/4 of the way to the gym, you reach B. So that should be the property of these 2 points. So let's say B is some position that's B units from home. The nice thing that we know here is that A then has to be 3/4 of the position of B. And similarly, B has to be 3/4 of the distance from A to the gym. So the nice thing is, since these 2 properties are kind of symmetrical, so A has to be 3/4 of this distance and B has to be 3/4 of this distance. This and this need to be equal for this to be true on both sides. And you can we can write this out as equations and see how to get that. But you can also actually notice that if I make the ratios in this 1, 3, and 1, as Pawan said, then the nice property here is A is now 1/4 of the distance from home to B, or essentially moving 3/4 of the way back from B to the home. And the same property applies here, right? Because this total distance from A to the gym is 4 units. So this is still in the ratio 1 to 3 to 1. So we have to convert this to kilometers in a second. But so this is A to the gym is 4 units. B to the gym is 1/4 of that. So this is again moving 3/4 of the way back from A to the gym, moves you back to B. So once we know this much, then we want 1, 3, 1 is the ratio between these 3 distances, and they should sum to 2 kilometers total. So this would be then 2/5. So we can 3 + 1 + 1 is 5. So this is 2/5. This is 6/5, and this is 2/5. So we can do this by saying A. So let's say it's A is 1 unit. So A plus 3A plus A is equal to 2 kilometers. So this we get A is equal to 2/5. So then we can fill in this. This portion is 2/5. This is 6/5, and this is 2/5. So now you can even confirm this that, okay, so if the distance from home to B was 8/5, moving 3/4 of the way back would put you at 2/5 kilometer from home. And then the remaining distance to the gym is 8/5 again, and moving 3/4 of the way back would put you back at 8/5. So either way, you can do this, or you could also write it out algebraically once you know if A is the position, is distance from home, and same for B. Then we know that A has to equal to 1/4 of B. And we know that B has to equal to A plus 3/4 of 2 minus A. And you can solve these 2 equations, but what you'll eventually get is the same things that we found here. So A is 2/5, and B is, in this case, it's the total distance, if we write the formula in this way, from home to point B, which is 2/5 plus 6/5, which is 8/5. So now what we're asked here is we want what is A minus B, the absolute value, and that's essentially the distance between point A and point B, because we're saying it's a point that's 8 kilometers from home and a point B kilometers from home. So what is this distance? And this would just be 6/5 here. Because of this ratio 1 to 3 to 1, we can just compute this directly as being 6/5. Any questions on this? The key thing to get here is that one, kind of if you simulate what happens at each step, you'll kind of see that it has to be moving between these 2 points. And now when to move between exactly 2 points, you have to just follow back what is the logic for moving from one point to the other, and that has to satisfy going from B to A as well as from A to B. And then you can either write equation like this, Or just think about, okay, if I have to move 3/4 back and 3/4 back this way, what should the ratios be here to make that work? And from that, you can compute this distance exactly. Any questions on this? Okay, let's move on to the last question. Any ideas for this question? Okay, I don't see any answers. This was a little bit of a harder question. Okay, so let's start by thinking about what are the possible sequences. Okay, so we know that the sequence has to start with 0, end with 0. What could be after the first 0?
A 1.
1, good. Can it be anything else?
No,
Why not?
because 0, it can't be 2 consecutive zeros.
Good. So okay, the next one has to be a 1. What could be after the 1?
A 0
Okay,
or a 1.
or a 1. Okay, so let's start writing out the options. So one of them is 0, 1, 0. One of them is 0, 1, 1, right? Now, what about if I had 0, 1, 0, what is the next one after this? What could it be?
A 1.
1.
A 1, good. Can it be anything else there?
And then
No.
No. So basically, kind of once we saw the 0 again, we reset, right? We had the same logic as initially what we started off with saying what can come after a 0, right? Here. So now once we have another 0, it kind of resets to what we're seeing here, right? So let's kind of forget about this first case. We can just say it kind of repeats from this. What about for this 0, 1, 1? What can we have after this?
A 0.
Okay, can we have a 1 there?
No, because there can't be 3 consecutive zeros.
Good. Okay, so basically we have the first 0, right? So after that, one option is we can have 1, 0. The other option is 1, 1, 0. So essentially we can think about it to reach the next 0, either it could be 1, 0 or 1, 1, 0. And these are kind of our two options. So let's think about, okay, after the first 0, 1, 0, right? What can we put after this? We know it has to be a 1, right?
yes,
Yeah,
And then what can be after that?
a 0.
a 1 or 0.
Yep, so either it's a 1, 0, and then we have another 1, 0 block, or it could be a 1, and then we have to have a 0 after that. So basically, I have a 0, then I can put either a 1, 0 or a 1, 1, 0, and then I'm back at a 0, right? So then again, my options are I can have a 1, 0 or a 1, 1, 0. And essentially, this keeps repeating. So once I have a 0, the next thing I can put is either 1, 0 or 1, 1, 0, and that puts me at the next 0 that I can have. Does this make sense? And now the nice thing that we know is it also needs to end with a 0. So to end with a 0, I can't just stop here or stop here. I have to include the whole thing, right? So the advantage is that now all I know my sequence is going to be of the form there's first going to be a 0, and then I can pick, do I want a 1, 0 next or a 1, 1, 0 next? Then after that, do I want a 1, 0, 1, 1, 0? And so on until I have a sequence of length 19. Okay, so now let's think about if I have 19 length sequence, how can I break it up into combining some units of 1, 0 and some units of 1, 1, 0? So give me some examples of what I can do.
You could do three sequences of 1, 1, 0.
Okay,
You could do 2 sequences of 1, 0 to get you to 19.
okay, so let's see what that would give us. So 3 times 3 for 1, 1, 0, that's
Sorry, I
9.
meant 5
Here's
1, 1, 0s.
Good, yeah. So you actually have to be careful because what about the first zero? Does that, so we have a sequence of length 19 that begins with a zero and ends with a zero, right? The first zero doesn't actually count within the 19, right? So what should this be actually? So this would give us 19, right? But we actually want 18, right? Because the first zero is extra, then we have a 1, 0, 1, 1, 0, and so on. Any ideas?
You could do 6 110s.
Okay, yep, that works. So this sequence is actually just 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, and so on. So that's good. That's one option that we can do. Any other ideas?
Nine 110s.
Good, that also works. So this would look like 0, 1, 0, 1, 0, 1, 0, and so on for 9 1-0s. So it's just alternating 0, 1, 0. That also satisfies all of them. Good. What other sequences are possible? Can I mix some 1-0s and some 1-1-0s?
You could do 4 110s and 3 1-0s.
Good. That works. Anything else? What if I have two 1-1-0s? How many 1-0s would I have?
6.
Good. Okay, so these are actually all the possible cases. Now we have to think about the number of sequences that satisfy this. So a few of these are easy. So when I have 6 1-1-0s, it's just going to be, I know my sequence will be 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, so on. So there's one sequence here. With 9 1-0s, that's also clear. It's just 0, 1, 0, 1, 0, 1, 0, and so on. So there's one sequence here. What about this one with 4 1-1-0s and 3 1-0s? Is there one sequence that fits that or more than one? So here I need to decide whether I need to put 4 1-1-0s and 3 1-0s in my sequence, right? I could finish all my 1-1-0s first and then put the 1-0s. Or I could put my 1-0s first and then put the 1-1-0s. Or I can mix them up, right? And these are all going to be the different sequences, right? I could put 1-1-0, then 1-0, 1-1-0, 1-0, and so on. So how many ways are there to have 4 1-1-0s and 3 1-0s in the sequence? So we have a total of 7 items, right? 7, 1, 1. Yeah, go ahead.
Is it 35?
Let's see. Yes. So how did you get 35?
I did 7 factorial over 3 factorial times 4 factorial.
Good, yeah. And why 7 factorial divided by 3 factorial times 4 factorial?
It's it's for combinations.
Good, yeah. So in this case, we want to do 7 choose 3, which is going to be of 7 things, 4 110s and 3 10s. There's 7 of those. You want to choose 3. So that's 7 factorial divided by 3 factorial times 4 factorial, which is 7 times 6 times 5 divided by 6, which is 35. Good. Now what about this one? 2 110s and 6 10s. This is also going to be combinations, but what's C1? So this should be 8C2. So 6 10s and 2 110s. So I have a total of 8 of them. And I want to choose, you can imagine that I have these things in a row, right? So let's say call a 110 something like A, and 10 is B. So I want to put 6 or 2 A's and 6 B's in a line. So this is the same thing because I can just take an A, replace it by 110 and a B and 10. So then it's asking how many, I can put AA, BB, BB, or AB, AB, BB, B, or so on, right? So basically I have now 8 letters in a row. And what I want to decide is I want to have 2 of them be A's. So basically then in the 8 letters, I want to choose 2 positions for A. So this is 8 choose 2. And what is 8 choose 2?
28.
Good. So this is, we can do the same thing, 8 factorial divided by 6 factorial times 2 factorial, which should give us 8 times 7 divided by 2, which is 28. So what should the answer be here?
65.
Good. Yep. So it's 28 plus 35 plus 1 plus 1, which gives us 65. Okay, any questions on this? Okay, I'm going to cover quickly one more method of solving this problem. And it's actually related to, we saw this approach for a different question earlier on Fibonacci numbers or recursion. And kind of that's going to be a little bit different, but we'll start off with the same idea here that it starts with a 0. And the next numbers are 1 0 or 1 1 0 and so on. So instead of thinking about the entire 19-length sequence, let's think about the sequence as starting off from a smaller sequence and building up. So the nice thing that we know here is that it ends with a 0, right? So that means that the sequence must end with either 1 1 0 or 1 0, right? Those are the 2 options for how the sequence could possibly end. We know these are the ways that it could kind of have a 0. So let's think about if I have some sequence, right? I had some sequence before, and let's say, so that has to end in a 0. Then I could append to it either a 1 0 or a 1 0, 1 1 0. So whatever the sequence before is, if it satisfies the properties, I could just add a 1 0 to it or add a 1 1 0 to it, right? So if I want a sequence of length 19, what I could do is actually look for, instead of actually finding sequences of length 19, I could actually make my problem into a different problem, right? I could say first, find me all sequences. So what I want to do is find a sequence of length 19 that ends in 0, or find the number of these. But what that is actually the sequences of length 17 that end in 0. And I could just add a 1, 0 to those, or the sequences of length 16 that end in 0. And then append a 1, 1, 0 to those. So basically, I can take my problem of trying to find sequences of length 19 that end in 0. This is actually equal to the number of sequences of length 17 that end in 0 plus the sequences of length 16 that end in 0. Is this clear? So I know a sequence of length 19 that ends in 0 should end in either 1, 0 or 1, 1, 0. So it's like thinking about working backwards. So if I know it ends in 1, 0, then the problem that's left is finding, okay, sequences of length 17 that end in 0. Then I could just add a 1, 0 to it. Or find a sequence of length 16 that ends in 0 and then add a 1, 1, 0 to it. Now I could actually kind of repeat the same process with sequences of length 17 that end in 0, right? And what would that equal to? So can I write that then as the sum of two other length sequences? So let's write this a little more generally. Maybe that'll help. So let's say f of n is the number of sequences of length n that end in 0. So we know that f of n, the number of sequences of length n that end in 0, must be equal to f of n minus 2. So this is the sequences that are 2 lengths shorter. And then those I can just add a 1, 0 to those, plus f of n minus 3. So these are 3 characters or 3 numbers shorter, and then I can add 1, 1, 0 to them. So the nice thing is once I have this formula, I can now build up. So we can compute, these are easy to compute, right? I can compute f of 1. So how many sequences of length 1 are there that end in 0 and that satisfy? Any ideas? So f of 1 should just be 1, right? Just starting with a 0 works. What about f of 2? Can I have a 2-character sequence that satisfies all the properties? So I would have to have it start with 0 and end with 0, right? So if it's 2 characters, it would just be 0, 0, but it cannot have consecutive zeros. So this would actually need to be 0. F of 3 would be 2. Or sorry, just 1, corresponding to just the string 0, 1, 0. And now I could actually compute all the future ones by doing f of 4 is equal to f of 2 plus f of 1, and so on. And I can compute f of 5, f of 6, and so on. And what the answer that we're looking for is f of 19, which is the sequences of length 19 that satisfy the properties. So what we're looking for is f of 19. And if you repeat this process, you'll see that we'll actually get the same answer as we got when counting the sequences here. We will still get 65 here. This approach is a little more complicated, but it's a little more general approach. So you can compute any, with higher numbers, it can be more complicated to do this casework. You could kind of just follow this recursion to figure out for any n how many sequences there are of that length that work, by knowing that you're always building up with either a 1, 0 as the building block or a 1, 1, 0. Any questions on this? Okay, that's it for today's class. We'll see you all next week.
Thank you.
Welcome.
Thank you.
Thank you.